Hello, my name is Rosalie Osborne Canuck, and this is my presentation on burnishing. Before glazes were in use, burnishing was the traditional method for making ceramics watertight. Burnishing realigns clay particles to make a smooth, watertight, and often shiny surface. Burnished pottery is fired at low temperatures because higher temperatures cause the clay to shrink, which destroys the burnish. Burnishing tools include a spoon. You can use metal or plastic. I prefer plastic because a metal spoon will frequently leave black streaks on the surface of the clay. A plastic bag and a burnishing stone or any polished stone. The burnishing tool that you choose will partially depend on the hardness of the clay that you are working with. The softer the clay, I would say to use a softer burnishing tool. For example, a plastic spoon. If your clay is harder, then I would use a harder tool, like a stone. Any kind of stone that is polished will work, a tumbled stone. But if the stone has any cracks or chips in it, then those cracks or chips will leave scratches on the surface of your clay, thus destroying the burnish. My research for this class focused on testing various chemical and organic ingredients in a pit firing. Some of the tiles would be isolated in aluminum foil saugers, while others would be in the open flame. I will perform future pit firings based on the analysis of the results. I used porcelain clay and a plastic spoon, bag, and a stone for polishing. The fire was made of charcoal, sawdust, pine needles, and wood built in a small barbecue grill. 14 of the 26 tiles were wrapped in aluminum foil with various coloring agents. The organic coloring ingredients included coffee, salt, and seaweed, while the chemicals used were copper carbonate, copper oxide, aluminum, manganese, nickel, titanium, and zirconium. From previous research into burnishing and pit firing, I expected some of the organic ingredients to cause some coloration, the coffee to make a dark brown color, the salt and seaweed to give some orange or yellow colors, and even the copper carbonate, I expected any kind of wine or burgundy color. Here is the copper carbonate. It's a green powder. The other chemical ingredients, I had no idea what to expect from them, if there would be any result at all, but because I had the chemicals on hand, I decided, why not give it a try? I made 26 test tiles, 13 round and 13 oblong. The 13 oblong and 1 circular tile were wrapped in foil with varying combinations of the organic and chemical materials. Here you can see 2 examples of what it looked like inside the aluminum foil. We have the test tile, some chemicals, salt, and some kind of organic material. And then you can see below all 14 tiles wrapped up. Using the wood, pine needles, sawdust, and charcoal, I built the fire, placed all the tiles in the fire, and sprinkled salt, seaweed, coffee grounds, and copper carbonate over the top of the whole thing. You can see pictures here of the fire setup. A variety in the distribution of organic and chemical materials should cause a variety of results in the final products. I built up the fire and let it burn for about 1 hour, then let it burn down to embers and cool overnight. Okay, so last night we let the fire burn for about an hour and then left the coals to just go all night long. Cooled naturally, and now this morning we're going to see what the result is. These three were partially buried in the pine needles. You can see that they absorbed a lot of black. Oops, durable too. Ooh, still warm. Ooh, really warm still. These are some that were in the sawdust. This isn't interesting.
Yeah, very.
Pattern. We have some burgundy wine color there. I expect that's from the sodium. Not sodium. Sanhot dong. This burns through. See if we can. Okay, now I'm going to unwrap the rest of these, and then I'll post the results. In these two photographs, you can see the front and the back sides of all 14 tiles that were wrapped in aluminum foil with the various organic and chemical ingredients. And here you can see all 12 tiles that were placed directly into the fire with the salt, seaweed, different burning ingredients, and the copper carbonate. And here are all 26 with the before and after pictures. Many of the tiles came out with a lot of black smoke markings. Partially, I think this has to do with the wood being wet from rain earlier in the day, and the pine needles themselves smoked a lot. Also, the tiles that were wrapped in aluminum foil should have been more protected from the carbon, but the aluminum foil burned, so some of the wood smoke got in and affected those tiles. As I expected, many of the tiles had some wine and burgundy colors from the copper carbonate. But unexpectedly, several of the tiles had an interesting white and black speckled pattern, I think from the salt. I have two of the black and white speckled tiles here to show you. Here's one. You can see the black and white speckled pattern on it. There you go. The other side is a kind of black, white, and a little bit of burgundy there in the middle. Just cloudy look. Here's another one. Again, we have the black and white speckled pattern. But the reverse is a kind of burgundy on one side with some gold. I don't know if you can see a little bit of gold right there. Gray in the middle and black on the other side. The tiles wrapped in foil were intended to test if any of the chemicals would produce color. I suspect that the fire was not hot enough to burn most of the chemicals. As a result, some of the tiles had very little change in color. I'd just like to show you some of the tiles that did not take much color to them and talk about what chemicals were with them and what I think happened. This particular tile was wrapped with copper oxide, salt, and pine needles. The salt is what gave it that little bit of pinkish color. The tile has a bit of gray on it. I think that is from the pine needles because the pine needles were slightly damp and therefore were creating a lot of smoke when they burned. But the copper oxide did not do anything at all. It didn't affect the color of this tile at all, so in the future I won't bother to use copper oxide. This tile was with nickel, seaweed, coffee only. The coffee was one factor in creating so much black on this, but also the aluminum foil that this was wrapped in burned, and so carbon from the fire got in and affected this tile. In this top corner you can kind of see some smoky dots. They are not clear dots but kind of hazy. I think that is the nickel. Whereas this one had very similar ingredients: titanium, seaweed, and coffee. Here's from the coffee and the seaweed, these black smoky marks. This one has some sharp black dots. That, I suspect, is the titanium. Now, this tile was nickel and titanium and seaweed. Here's some black and gray from the seaweed, and at the top of this tile you can see there are some hazy black spots and there are some sharp black spots. I think it would be the hazy black spots are the nickel, similar to this tile, and the sharp black spots are the titanium, similar to this tile. Some of the chemicals didn't burn and also prevented carbon from absorbing into the tile, thus creating white spots. Two tiles in which the lack of carbon absorption is clearly visible in the tile are, first, this one using aluminum. You can see the white spots on the gray background, and the zirconium. This is one of my favorite tiles, where there's a nice rich black and gray with the white spots on it. Because the fire smoked so much, I inadvertently black fired a few of the tiles on only one side. Black firing is a process in which the artist intentionally creates a very smoky environment to make the surface of the clay a deep, rich, and sometimes metallic black color. One easily fixed problem with the firing was the distribution of tiles compared to the fire. Too many tiles were too far from the heat at temperatures hot enough to burn the chemicals. Next time, I should build a larger, hotter fire in a large steel barrel and insulate the barrel to contain the heat. This will help create more vivid colors on the tiles. I should also use thicker foil or double wrap the tiles to counteract the burning aluminum. I hope that you enjoyed this presentation. I hope it was interesting and informative. I had a great time doing the experiments, and I look forward to more opportunities to play with fire and clay.